Okay, so looking at sinusoidal applications day 2, what we're going to do today, the only difference is everything that we're going to do is going to be in radians. What that means is when you're finally solving an equation or if you're subbing in a number, you have to make sure your calculator's in radians because our k value is going to be different and that's going to influence what our final answer is if our calculator isn't in radians. So the first question says the top of a flagpole sways back and forth in high winds. The top sways 10 centimeters to the right, 10 centimeters to the left from resting position 240 times every minute. T at 0, we're at the resting point at time 0, which would be right here. And then it starts moving to the right. So right away on my graph, I've established right and left. And I've said that my time is in seconds. Now the first thing I'm going to need to do is find out how long one cycle is. Now one cycle is going to be 60 seconds divided by 240 cycles, which is 2.5 or 0.25 seconds. So we're going to start at 0, go to 0.25 seconds, and there's our full cycle. If you wanted to do another one, boom, there's 2 cycles. Cut it in half, go up, cut it in half. We'll cut this one in half as well. Cut that in half again. Go up. Cut this in half. Go down. And notice this isn't exactly on the points, but it's close enough. I'm not asking you to use the graph to actually solve anything. I'm just asking you to graph the actual equation here, or the points. And now I'm going to be connecting the dots, and it's probably going to look terrible because I'm trying to do this on my mouse pad, but you'll get the general idea. And we go down. Let me go back up. And there we go. 2 cycles. Okay. Determine the equation of the sinusoidal function, blah, blah, blah. Our amplitude is 10. We found that because it goes right 10, then left 10. Right 10, left 10. Equation of the axis is 0, so we don't have any c value at the end. We've started at 0, 0, which is nice because we don't have a phase shift at all. So all we have to do is find our k value. Rather than doing 360 divided by our period, we're just going to do 2 pi divided by our period. And if you just want to leave it like this, 2 pi divided by the period, unless it's an easy simplification, you can. Now this one would be fairly easy. You could reduce that down and actually get 8 pi. But if you wanted to leave it as 2 pi over 0.25, that's totally fine too. Now the next part of the question asks, if the wind decreases slightly, so we've got a reduction of 20%, what's the new equation? For you people in physics, you should know that nothing will change other than the amplitude from this decrease. That's the way periodic motion works. So, if we decrease the amplitude by 20%, then the equation just changes to 8 instead of 10, because 20% of 10 is 2. And there's your new equation. Alright. For the second question, I'm not actually going to graph it. I'm going to let you guys graph it on your own. The one thing that you have to be careful with is time starts when the chair is at a minimum height. What I'm going to do though is I'm going to go through every part of actually making the equation here, and then I'm going to let you guys actually make the final equation once you've graphed your situation. You're going to have to pick either a starting point on the equation of the axis or at the maximum or minimum, depending on whether you're using sine or cos. So if we're determining the equation for this whole situation, we've got a Ferris wheel that has a diameter of 23 meters. It starts 0.25 meters off the ground and lasts 3 minutes with 6 complete revolutions. So first I'm going to find my amplitude. Now I'm going to find my amplitude by doing max minus min divided by 2. 23.5 minus 0.5. The way I got 23.5 is the diameter of the Ferris wheel is 23 meters, and it starts 0.5 meters off the ground. So 23 plus 0.5 would be my max, and then my min is 0.5. So I've got an amplitude of 11.5. Now the equation of the axis is the same kind of thing. We're going to have max plus min though. We still use those same two values, and the equation of our axis here is 12. Finally, when we're finding our k value, the first thing we need to do is find our period. Now I changed it to seconds. I like to have a bigger number here. So I did this as 180 seconds and 6 revolutions. So we did 180 seconds divided by 6. So that means 30 seconds per revolution. And then I used my k value. I did 2 pi divided by 30, which just becomes pi over 15. So now the only thing that you're going to need to solve for is your C and D value, so your phase shift and vertical translation. Everything else has been given here. When you're done that, you can start working on the worksheet for today.